Hello, this is Professor Urbis White. Today we will do radicals, but we are going to cover the division of radicals. So let's get started. What happens when you have two radicals and you want to divide them? Here it is. When the index is the same, you can just divide them. You can put them together in the same family. When the index is not the same, you can divide the whole numbers. That's fine. Just try to go to the exponent notation. So this one is a to the 1/n divided by 1/n. What do you do when you have that situation? You subtract, put it in the same denominator, and you're going to have this inside and this outside. Okay, so it's not the same as this one. When the indices are different, you cannot just go ahead and put them together randomly. Let's do some examples. Can I put these two together? I think I can. x6, x7. Okay, then what do you have? Your sixes will go, you'll have 1 over x in the denominator. All right, you can also write this as that way. Okay, that makes sense. And they didn't ask me to rationalize the denominator. That's as far as I go. Okay, so let's go do a couple of things. These are the same indices. Can I put them together? That might be the fastest way of dealing with this problem. So let's put them together. Now let's write this. 48 divided by 3, that's 16. You have a 9 minus 1, that's 8. And you have 13 plus 2, that is 15. Did you see how I did that? Okay. Now, you can have this intermediate step, so let me write this down. Let's see. This may be too fast. 48. You have 3. So you have x. You have 9 minus 1 when this x moved up. And this one is 13 plus 2 when this moved up. So that will give you 16, x8, y15. Now let's look at that. What is 16? 16 is 2 to the 4th power. What is 8 if I write it in terms of 4th root, 2 times 4? What is that one? I have 15. I can do this way. 3 and 4, that will get me to 12. And then I have another 3. Let's take things out. 2 comes out. This one comes out. This one will come out. What's left behind? You're going to have a 4th root of gone, 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 y cubed. All right, so it will make our lives a little easier when maybe I put that under one radical when the indices are the same. A second type of problem that you may have is they are asking you to rationalize the denominator. Rationalizing the denominator means get rid of it. Get rid of all radicals, whatever index you have. Now, I know that this thing is going to give me x. I know that, and so to get rid of that, I can multiply top and bottom by radical. Look what you're going to get. You're going to get a 3 radical x, and this will give me x. And guess what happened? I just got rid of the radical in the denominator. That's a good thing. That's what I wanted. Well, what happens when I have a cube root? Well, I know this. If I have a cube root, if I multiply it 3 times, I get rid of it. So this is going to give me that. Okay? Well, I have one of them. I need to get the 3. So how many am I missing? 2. So I'll put, here's 1. Here's another one. These 3 will give me y. What am I going to have at the end? 3 cube root of y, that's y squared. What do you have in the denominator? Y. Well, I missed 2 in here. Let's see how it works with this one. I know this fact, right? So I have 2 of them. How many am I missing? 1. So I can put 1 more. Look what happens. You're going to have, these 3 is going to give me that. And I have 3 cube root of y. Do you see the difference? Here I missed 2, here I missed 1. That's the only difference. Well, sometimes things are a little bit more complex. Okay, so let's say I want to rationalize the denominator. Well, let's see what I can do. Can I simplify things at the beginning? Always simplify first. Okay, so let's try to write that. What does that mean? Simplify first. This one is 3 times 7, right? This one is x squared, and this one is y. This one is 3 times 25. This one is x, this one is y fifths. Now I'm going to put everything kind of in one happy family, and then let's get rid of some of these numbers. I get rid of this x, so I have a 7 on top. I have an x on top because these 2 will go. I have a y to the 4th at the bottom. And then I have a 25 at the bottom. Guess what? These 2 can come up because they're perfect squares. They can come up as 1 over y squared and 5. What do you have left behind? You're going to have a 7x. Alright, and guess what? That is a pretty good deal. I didn't even have to rationalize the denominator, and you can write it that way as well. 7x over 5y squared. Okay, that's another example. Actually, it's a pretty good one. Okay, what do I do if I have like an expression in the denominator I want to rationalize? Well, I can split these guys, remember? And I have a radical in the denominator. I need to get rid of it. I know this. When I multiply this 2, I'll get this. Okay, well, why don't we use that? So I multiply the bottom and top by that. And look what's going to happen. In the denominator, you're going to have this. In the numerator, you're going to have this. Well, that's pretty good. But let's not mix this up with this problem. You see, this radical is on top of both terms, and this radical is on top of only one term. So how does that affect the outcome? Now, if I multiply this by this, guess what's going to happen? It's not going to get rid of all the radicals, so that's the bad approach. But if I multiply this by its conjugate, what we call a conjugate, this will give you a minus b times a plus b. And you know what that is? A squared minus b squared. So what does that mean? When I multiply these 2, I'll get x, which is the first one squared, minus last one squared. And that gets rid of that. So instead of multiplying it with minus 1 or something funky like that, I can multiply top and bottom by its conjugate, which happens to be this. And you do that when the radical is only on one of the terms. Look what happens. You get rad x plus 1 on top. At the bottom, you're going to have first one squared minus last one squared, which is a very powerful tool. Okay, what happens, let's see, I have 2 more pages. What happens if I have this situation and I have a cubic? Remember, to get to the cubic, what I need to do. I'm assuming in all these problems, the variables are positive. So to get to the cubic, what do I need to do? I multiply this twice with that so that I get to 3 of them. Okay, so in this case, what do I get? I'm going to get cube root on top, and I have 2 of them, so that means x minus 1 squared. In the denominator, I have 3 of them. They cancel out, so you'll have x minus 1. But do not mix that one up with when the radical is on one of them. So in other words, if I go and I do this, its conjugate, that's not a good approach. That's not going to get rid of the radicals for you. Actually, this is a little bit more complex case, but what you need to do when it is like that, the cubic, you have to remember this cubic formula. That is a minus b, a squared plus ab plus b squared. Right? So what does that mean? I need to multiply top and bottom by that. And it's going to become more complex, but that will get rid of the cubic. Okay? So I'm not going to finish this one because there are no examples in intermediate algebra level. But remember that you cannot do this to get rid of the cubic radical like that in the denominator. All right. Sometimes in some problems they will ask you rationalize the numerator. That means get rid of the radical in the numerator. I saw this in some books, but not in all. So rationalize the numerator means get rid of the radical. So what do? This time you'll end up with the radical in the denominator. So when you read a problem, make sure that they're asking either denominator or numerator, but usually 99.9% of the time they are going to ask you to rationalize the denominator. So if they don't tell you anything, just go ahead and rationalize the denominator anyway. Well, how do you do this one? Same way you were doing the numerator. You multiply by its conjugate. And you're going to get x minus 25 on top. And at the bottom, you're going to have this. And it's going to be left behind.